Liz Rice has made this marvelous book about container security. We invited her and Eoin Woods into the studio for a friendly conversation. This episode was made possible thanks to Gotopia.tech.
So Liz, I thought maybe we'd just start with the most obvious question, which is, how come you came to write a book on container security? It's a really important topic, but it's also quite a specialist one.
Yeah, so I've been working with containers for quite a few years now, and obviously they've exploded in popularity, over the last 4 or 5 years. I think we've gone from like, what even is this Docker thing, to lots of developers, a huge proportion using containers. And I've been working in container security now for about 4 years. I've always been I've come from the developer angle, and I've always been really interested in kind of how things work, what's happening under the covers. And with my sort of security perspective, it's like, how does the way that a container works, how does that present issues for security? How does it create attack surfaces? I've been doing talks and writing blog posts and creating content about containers and container security for quite a while. And then when O'Reilly approached and said, did I have an idea for a book, I kind of knew that, well, container security is kind of what I've been working in and what I know about. And it was really nice to have the opportunity to dig in more detail than you can necessarily cover in a 40-minute conference talk. In a book you can really dive into the details.
Yeah, which you do. I mean, there's a lot of detail in the book to really help people understand it, which, I mean, it's a great aspect of the book. And I noticed, of course, your day job's at Aqua, who are in the
Yes.
area of cloud security, but you've also got a CNCF affiliation. What's that? And
Yes,
does that relate
yes.
to container security?
Yeah, so I am currently the chair of the Technical Oversight Committee for the CNCF, which, in case anyone doesn't know, it's the organisation, part of the Linux Foundation, that owns Kubernetes, Prometheus, a whole host of cloud-native projects. And with the TOC, we're really the group that assess whether projects are cloud-native and should join the foundation, and at what level of like sandbox, incubation or graduation. So that gives me a really interesting vantage point over the world of cloud native in general, and I get to meet and talk to some really, really interesting people. And security is just one part of the cloud native landscape, but it is a very important part. So it's a privilege to be getting that view across the broader landscape, not just security.
Yeah, there was a lot of hard work, partly in your spare time, I suspect. But security is often forgotten. It's rather nice to actually have somebody actually leading a kind of technical committee who's actually focused on security. That's really good. I was wondering, because you've got quite a broad view of containers, and one of the nice things in the book, I just love the way that you sort of build a container at the shell prompt. And I think there's lots of us have come to containers, and we got Docker and we thought this is this magical packaging technology and seemed to keep everything safe, and then we weren't quite sure how safe it was, and then you wrote a book on that. Can you just explain, for someone who's just used containers, what the essence of a container really is?
Yeah, so I think if your experience of containers is running them, Docker run and maybe execing into a container, there is this sort of tendency to think of them as virtual machines. Like, you used to hear this phrase, lightweight virtual machine, and it's so misleading, because containers, all the containers on a given machine share the same kernel, which is the fundamental difference between a container and a virtual machine. Virtual machines have their own kernel. And really what a container is it's a process, or maybe several processes running under Linux. And that process is isolated from the other processes. It uses mechanisms called namespaces and C groups, and it has its own view of the file system. But really, from the host perspective, it's just another process. It's really nothing special, and that has huge implications for security, because the isolation is, it's only so much. It's not the same strength of isolation as you would get from virtual machines, largely due to that shared kernel.
So the VM's kind of a thing with an operating system kernel in it. The container isn't. You sort of hinted a bit there in that question about they are different from a security perspective. Well, from the perspective of people who use them as opposed to people who are deeply embedded in building them, what do you think? How would you compare and contrast them specifically from a security perspective? What does that shared kernel mean in terms of the security things you need to be aware of?
So the main consequence of that is what happens when things go wrong. If you do manage to escape a container, you're a bad actor and you've managed to compromise a container. If there is a way of escaping onto the host, you can potentially escape through the kernel if there's a vulnerability in the kernel, and we have seen vulnerabilities in the kernel, or if there's a vulnerability in the container runtime, it's possible to escape from the container onto the host. And I mean, it's not like this isn't ever possible on virtual machine. There are, potential, that there have been security issues in virtual machines as well. But the fact that you have this shared kernel makes it just so much more likely that if something goes wrong, you're going to get from the container onto that host machine where all of the containers are running. And once you're on the host, particularly if you're root, you've got access to everything.
Which most containers in container systems I've worked with, they are root, right? I mean, that's one of the constraints.
Yeah. This is one of those kind of really fundamental things that I really want people to improve about, their container security. You're running as root by default today, at least. There are exceptions. If you're using Podman, that doesn't run as root by default. If you're using OpenShift, that doesn't run as root by default. But for most people's experience running with Docker, running containers on Kubernetes, unless they've specified a user, by default, they're root. And as I've shown in the book, and as I've shown in a few talks before, that root identity is exactly the same in the container as it is on the host. So if you do somehow escape from the container, you're root on the host. And I guess another thing that's quite a big contrast between containers and virtual machines is you can escape the container through just misconfiguration. It doesn't necessarily require an actual vulnerability in the kernel or the runtime. You can, for example, if you mount the whole host file system, there's nothing to stop you doing this. You can mount root on the host into a container, running as root inside a container with access to the full host file system. The world is your oyster as an attacker.
Yeah. That can only sound like a bad thing. Yeah.
Yes.
I mean, one thing you talk about a bit in the book, and which I think has got a lot of, you were just talking about parallels with other, previous technologies, which also is a concern other places, but strikes me as really important with containers is software supply chain security. So, that's the posh name for pulling in all your dependencies. This has worried me for years with things like Maven and Node, and you import one package and you seem to end up with half the open source universe, and you don't know much about it. But yeah, containers have always worried me a little bit more. I don't even really know why. Maybe it's emotional, maybe I don't know enough about them. But it seems like you're pulling down really complicated bits of software which you probably aren't very familiar with, and they're all being stacked in this kind of integrated stack, and you need all of it to make it work. I mean, how do you even go about thinking about software supply chain security with containers?
Yeah, so I think the reason why it feels more complicated in a world of containers is because every single one of your containers is running with its own set of dependencies. This is one of the wonderful features of containers is you can package up an application and all its dependencies into one image and ship that image around. So every image has its full set of dependencies. So every image could be different, and you've got to check every one of those images because they all might have, you've got this forest of images, and somewhere in there maybe there's a vulnerability, and it can seem quite daunting that, particularly if you were sort of used to a traditional security process where, you SSH into a machine and apply patches. You can't really do that in a containerized environment, particularly if those containers are coming up and down, pretty frequently. Average lifetime of a container in production is around about a day. So imagine having to patch thousands of containers, and you just can't do it manually. So automation is really your friend. And like everything else in the cloud native world, the more we can automate things, the less human interaction you have, the less chance there is that somebody's going to make a mistake. And a lot of security issues are not people behaving badly deliberately, they're just slip-ups, people leaving things open inadvertently. And so automation is your friend. Vulnerability scanning is particularly important for the supply chain.
Yeah, and I mean that point about people don't do daft things deliberately. I mean, I think that's a really important point, isn't it? That there seems to be so much so much technology that from a security perspective is just a minefield for people to kind of wade through. I mean, I always describe in my security talks that if you had to create an attack vector, you'd start with a web browser. It's such a rich environment to build attacks in that actually, even as soon as you look at it, a security person goes, yeah, that's a huge security problem.
GOTO gives you the chance to learn from the brightest minds in software development, join community meetups and highly rated conferences, and take deep dives on your favorite topics with masterclasses.
How do you think about containers? I mean, do you think there's things that are in configuration today that maybe should be harder to change, or do you think there's particular vulnerabilities in the way containers are configured that could be improved? I mean, especially from a CNCF perspective.
Yeah, so there's all kinds of aspects of how you run containers and how you run your overall orchestration system. These days it's probably Kubernetes. Over time, the settings for Kubernetes have got better by default. So, gone are the days when by default you would leave an administrative dashboard open to the internet by default, which was that was a thing, and fortunately, if you take the standard install tools now, you will get things like secure API ports rather than just allowing unauthorized access. So the default settings have improved a lot over the past couple of years or so. There's still a lot of room for improvement. One thing that I'm quite excited about right now is rootless containers, which is, as we were talking before about how, by default you typically run as root. Rootless containers mean that although from the container's perspective, you appear to be root, it's not actually root on the host. And that's a huge improvement. And in fact, yesterday, as the date of recording, Docker released their latest update, which has moved support for rootless out of experimental. Still, there's still some work to go in the Kubernetes world to bring rootless. There are some experimental demonstrations of running rootless, but it's not really the production sort of GA right now. But I'm hopeful that we're not too far away from a future where by default we don't run as root, and that will be a big step forward.
Yeah, that sounds like great progress. Yeah, and good to be able to influence that kind of thing, because one of the technologies you've mentioned a couple of times is Kubernetes. And I think in many people's minds, if you talk to many software developers, containers and Kubernetes and containers, that they're really kind of almost the same thing. And I mean, in the book, you don't spend a lot of time talking about the orchestration technology. What complications do you think Kubernetes brings to the container environment from a security perspective? Because in the book, you do allude to the fact that it certainly doesn't make things easier.
Yeah, so one of the reasons why I didn't talk about Kubernetes security in the book is partly it would have been 2 or 3 times the size, and partly because it's changing more quickly. I think that the fundamentals around how containers work are pretty well understood, whereas I think there are lots of aspects of Kubernetes and Kubernetes security and the complementary products that sit around Kubernetes, like registries, where there's still lots of improvements and lots of great innovation going on. Not that there isn't innovation going on in the container space, but I wanted the book to, not be out of date in 6 months or a year's time. And I think that Kubernetes security is moving sufficiently quickly that there would be a danger of things being a little bit aged after, a year or two.
Mm-hmm. And where would you recommend people go to find out more about Kubernetes security aspects and, how to track that? Because it is moving quite quickly, isn't it?
It is moving quickly. And in fact, I co-authored an O'Reilly report with Michael Hausenblas, who's now at Amazon. And we did that a couple of years ago. And I definitely feel that report is kind of due a refresh. It's got some sensible things in it, but it's, there are things I would like to update in that book. So in the absence of that, I would say the Kubernetes documentation itself has got better, and there are people who are writing, sections in Kubernetes docs about security aspects. So things like if you want to make sure you've got secure connections between your different Kubernetes components, that's all documented now. There's quite a lot of best practices documented there. There's also there's Slack channel on the Kubernetes Slack dedicated to security. And I think one of the really nice things about Kubernetes in general, the CNCF in general, the whole community is very welcoming. So if you do have a question, whether it's about security or anything else, coming into the Slack channel, there will be people to help. Asking on a mailing list, there will be people to help. So I definitely encourage people to kind of embrace the community, and it's one thing to read a book, but you can also find people who know this stuff, and they'll be, they're happy to help.
That's terrific to hear, yes, because it makes such a difference when you connect with a human being who can actually point out the bit of the book you've misunderstood. So
yeah,
that's really important. Thank you. So a lot of these technologies are often sort of bundled into a broad area people call DevOps, which is a terribly undefined word, drives me mad. But if we just take it as meaning smoothing the path from development into operations, that there are, even if I'm a great fan of the integrated teams where you haven't got a silo, and a former colleague of mine had a terrific phrase for it. He said, the desert of responsibility in between dev and ops, and you try and take that away. You do still have specialists in the teams. When it comes to container security, I know the simple answer, the answer I always give my teams is security is everybody's problem. But when it comes to container security, who do you think where are the key responsibilities? What kinds of people do you need involved in your project that you're going to get the right attention on it?
Yeah, you use the phrase DevOps, and people also use the word DevSecOps, and I think that just goes to illustrate that actually there's lots and lots of skills involved, and people like to pretend we can just sort of mush them together and it will all be magic. So and actually, that's a big cultural change. So I think it reflects the fact that you're going to need people who understand how to operate your cluster, your containers, how they're dealing with deployments and rollouts and scaling and all that side of things. You've got your developers who understand the application, and you've got security specialists who understand things like, well, if we do have a particular vulnerability, what's the impact of that? There's lots of kind of jargon in the security world that can be a bit impenetrable, and you need people who know how to navigate that and really understand, if we find a particular security flaw, maybe we're scanning our images, we find, here's this terrible critical vulnerability, what should we do? And you need people who understand how to investigate what that really means and can ask the right questions of the developers and the operators to figure out what that overall response should be to a particular vulnerability or an incident even. So yeah, you need all those skills, and how those are organized in different organizations and how they're brought together into different teams. I think that's something that our whole industry is working on, and figuring out how to deal with that effectively.
Yeah, agreed. I don't think anyone's got an easy answer to it, but yeah, it's important we'll at least agree what the goal is and sort of move in that direction.
Yeah, there's definitely there's an aspect of tooling where, security tooling in particular, where I would say most security tooling is really at the level of, telling people that issues exist. There are, if we think about things like runtime security, technology exists. There's some really great tools. I mean, I'm working for a vendor, so I would probably think that, but there's some great runtime security tooling that can prevent your containers from doing untoward actions. But in reality, most people are not using that yet, and they're mostly in the world of kind of even trying to identify what the issues are, let alone how to react to them, how to manage them, how to prioritize different security concerns. So I think that the security industry and the container security industry is trying to level up people's understanding of security tooling, and but things like how do you deal with these issues is still requires quite a lot of human expertise right now.
Mm-hmm. Yeah, agreed, absolutely. In fact, I think one of the big security concerns is over-reliance on tooling, isn't it? That we've bought a load of tools, or people are trying to achieve DevOps the same way. I bought a load of tools. Why didn't I get DevOps? It's a huge danger in security.
Different tools can report different results for completely legitimate reasons. I was just recording a talk earlier this week about different vulnerability scanners and how you can. One really great example is there's two different ways of scoring vulnerabilities. It's called CVSS, Common Vulnerability Scoring System, but there are two versions in common use today, version 2 and version 3. If you use two different scanners, one of which is using version 2 and one of which is using version 3, they're going to show you completely different scores. They'll probably show you the same set of vulnerabilities, but under one scoring system, something could be critical, but only medium in the other. And I think as a user, unless you kind of know about these scoring systems, you just look at those results and think, well, what do I do with that? How can I make sense of this? So there's quite a lot of both education and improving how that is communicated.
There's so much jargon in security that a lot of the tools still talk in jargon. And the other thing I observe with security tools, because we use quite a few at Endava and we're constantly looking for the holy grail one, but an awful lot of them, dare I say it, with all due respect to the vendors, warmed over versions of the batch ones that used to be run at the end of the week or the end of the sprint or even before the release. And of course, teams now want to be running them every time there's a check-in, and actually lots of the tools are not very involved in that direction. For integrating security tools into your dev environment, which I think for containers is, we were saying earlier, so much more important than it used to be. I mean, how have you found that teams have approached that problem?
I think one thing that I've seen, particularly in that kind of CNCF community world, is that developers are more and more aware that, security is a thing, and we can't just sort of develop an application and then somebody else will deal with the security later, because they're supposed to be shipping function every week or every day or however frequently. So I mean, we've called it shift left, across the industry, that idea of moving security earlier into the development process. So I think developers are increasingly aware that there's probably something we need to do here. So there are things like, building scanning into IDEs, building scanning into build pipelines, things that GitHub have done to start exposing vulnerability information through the, Dependabot alerts. And this is all really good for raising awareness to developers that, okay, you may actually need to update this particular library because it's got a problem.
Yeah, it's just as much your problem as everyone else.
Yeah.
So we've covered quite a lot of ground there. I mean, I'm really interested. Did you just have all this background knowledge and it kind of collided with an idea for a book and you just wrote the book? Or did you kind of start off thinking, I know a lot in this area, but as you wrote the book, you kind of thought, my goodness, what a lot of other interesting areas. Did you have to learn quite a lot as you went? Or was this just something
there were
you've done
definitely
a long time?
areas of this where I could almost use the book as an excuse to dig in more detail.
Spend more time on it,
kind of refresh my memory. So one chapter in particular, where I talk about networking. Back in the day, my first kind of professional computing job was writing network protocols, and I knew all that stuff, but it had been a while, and I had to go and have a chat with a few friends and just kind of remind myself. So what actually happens?
Yeah, exactly.
Remind me how the ladder diagram.
I vaguely remember that about here something magic happens. Yeah.
Yeah. So, and actually, it was quite interesting. My mental model was a little bit, not quite right, and it was really good, to have that refreshment and update my.
It's quite nice to have the excuse to spend the time, isn't it?
Yeah.
No, that's really interesting. Thanks. So. It's not a big book. In fact, one of the things I was impressed with is you cover ground quickly. You don't hang around, and you really make the point in a very structured and rapid manner, which I was very grateful for. It's less than 200 pages. But what from that, if you had to boil that down, what are the 2, 3, 4 messages that you think people building, operating, using containers today really need to take away?
Okay, so I've got sort of, like a couple of favourite bits of what I find really fascinating that I think are interesting and important. But maybe I will answer the question in another way first. So the other way I'll answer it is, although I'm not a big fan of checklists, because a lot of security does involve people kind of trying to tick boxes on a checklist without necessarily understanding what those items mean. So I'm not normally a fan of checklists, but nevertheless, I wrote an appendix in the book that I called a checklist, but it's really more of a set of questions to try and help people think through what security issues are important to them. Do they understand? Are they scanning their containers for vulnerabilities?
Yeah, the thing I really liked about your checklist was you say there's no checkboxes, and it's not 5 words. It's quite a long sentence that really makes you think, oh, actually, I'd better stop and think about that rather than, yeah, that's fine.
Yeah, because there's no one-size-fits-all sort of solution. Everybody's security, everybody's deployment is different. The data they're looking after is, different and varies in value. The likelihood of attack varies. The complexity of the applications vary. So I don't think there's a one-size-fits-all. But I hope those questions will help people kind of think about what's important. But the other way I'd answer that question of what are the important messages? I think if you're using containers and you want to understand the security implications, just really understanding that they are Linux processes makes a huge difference to how you think about attack surfaces and the sort of foundational mental model that you need. So I definitely recommend the sort of chapters where I talk about container isolation and how a container is built up, because everything else kind of comes from there, I think.
That's great. It's a really easy message and one with a lot of implications for someone to think about once they've actually got some containers running out there in the wild. Thank you, Liz. It's just been an absolute pleasure to talk to you. I think we could talk for another hour quite easily. But, I'm quite sure we won't be allowed to. So thanks ever so much for taking the time. I've certainly learnt a lot. I think there's a huge amount there for people to learn, take away, and just improve security in the operation of their containers. Thank you.
Oh, it's my pleasure. Thank you.
Subscribe to the GOTO YouTube channel now for ad-free videos released almost daily, and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.